All right, so objective 8.6, trapezoids. So we're going to briefly discuss a kite. A kite is just a quadrilateral with exactly two pairs of congruent consecutive sides. That means that AB and AD, they're consecutive, they're side by side. Those two would be congruent, and then the other two sides, BC and CD, would be congruent. There would be, the diagonals would be perpendicular, and then one pair, and that's the key phrase, one pair of opposite angles would be congruent. So if you look in your picture, if the angles B and D are congruent, then the angles A and C are not congruent. What I really want to get to today is the trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides are called a base. The non-parallel sides are called legs. So if you think about a base as being something that you could sit it on, well, you can see in the trapezoid, if I needed to sit the trapezoid down on something flat, those two sides are parallel, so they're going to be level with the ground, and it would sit upright. Now, the base angles of a trapezoid are two consecutive angles whose common side is a base. Hopefully that makes sense to you. If the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. Kind of like with the triangle. You've got to have the two legs of the triangle congruent. And when we have an isosceles an isosceles trapezoid, we have some very specific theorems that can come from that. So these three things only exist if we know we have an isosceles trapezoid. So if we have an isosceles trapezoid, then the base angles will be congruent, meaning that pair of base angles, BC is one pair, AD is a second pair. So that pair would be congruent to each other. If we have a trapezoid, if we know that one pair of the base angles are congruent, then we can say it's isosceles. That's what this second theorem is saying. If we know at least one pair is congruent, then we can say that that trapezoid ABCD is isosceles. And the other thing that would be special is if it's an isosceles trapezoid, then we can say that its diagonals are congruent. Also, if we know the diagonals are congruent in a trapezoid, then we can say it's isosceles. Okay? So if it's isosceles, the diagonals are congruent. That's one thought. Another thought that means the same thing is if the diagonals are congruent, then we can say it's an isosceles trapezoid. Why do these things make a difference? Why do I need to know this in life? You got to know this in life because you got to get a high school diploma. And the only way you're going to get your high school diploma is if you pass the geometry class. That's why you need to know it. All right, so this is just saying that last thing that I was trying to stress to you about the angles being, the diagonals being congruent and it being isosceles, or if it's isosceles and then the diagonals are congruent, that's called a biconditional statement. That was kind of sloppy. That's called a biconditional statement. That means that if it's true one way, it's also true the other way, forward and backward. All right, so here we go. If I got to find the measure of angle A. Okay. So what do I know? Well, I know that these legs are congruent. Are the legs being congruent and parallel going to mean something to me? Yeah, when I look right here, that's the same picture that I have. So that means this is an isosceles trapezoid. Okay? If it's isosceles, what do I know? I know if it's isosceles that these base angles, according to this 663, the base angles are going to be congruent. So that means that's 100 and that one would be 100 because those are base angles. So base angles congruent. Angles are congruent. So angle C is going to be congruent to angle D, and angle B is going to be congruent to angle A. Okay, great, but how do I figure out what angle A is? Well, angle A and angle B are congruent. So they could both be represented with an X. When we don't know what something is, we call it X, and then we try to figure it out. Wow, it sure would be nice to know how many total degrees are in a trapezoid. I think I can figure that out. How many sides do I have? 1, 2, 3, 4. So if I use my handy dandy formula, yeah, remember that from a couple of weeks ago? 4 minus 2 times 180 degrees. That'll be 2 times 180 degrees, which will be 360 degrees. So a trapezoid is still a parallelogram, and all parallelograms have 360 degrees in them. So what I can do is say that all 4 of those angles added together would equal 360 degrees. So x plus 100 plus 100 equals 360 degrees. That's probably 360 degrees is probably going to be the next magical number that we use over and over again. So let's type this in. So I'm going to clean this up in my head a little bit. This is just, that ain't going to work. This is just going to be 2x plus 200 equals 360. I just added the x's together, and then I added the hundreds together. And what am I getting here? $80. X is 80. So this angle is 80, and that angle is 80. So the answer to my question, angle A, is 80 degrees. All right, see what else we got going on. All right, so same scenario. Both of these problems are going to be isosceles triangles, okay? So KB is 21.9. And MF, which is the whole piece right here, it's the whole diagonal, is 32.7. And I need to find FB. So what I'm looking for is just this little part in green. Okay, well, the diagonals are going to be congruent. It's isosceles, so everything is going to break down like you would expect it to. So if KB is 21.9, then get rid of my highlighter here. Then BM is also going to be 21.9. And so that means if the whole piece is 32.7 and I subtract it from 21.9, or let me say that the other way around, If the whole piece is 32.7 and I subtract that BM piece from it, which is 21.9, that's going to give me FB. So 32.7 subtract 21.9. 10.8. All right. Finding the measure of angle F. Well, that's pretty much like the first problem I worked. So base angles are the same. So this would be an X, G would be an X, and I'm going to say 2X plus, I don't know what 49 and 49 is off the top of my head. It's still going to be 360 because that's what it was when I added them together the other time. $360. So let me step back and look. 2x plus 49 equals 360. X will equal 131. So angle F would equal 131 degrees. Okay, so there's some problems when you just have some numbers to work with. What happens when we have variables to work with? First of all, we're not going to do example 5. You're not going to see a problem like that. AD is 12x minus 11 and BC is 9x minus 2. Find the value of x so that ABCD is isosceles. So this is, if we go back and look, we're talking about an isosceles trapezoid. So that means according to, let's erase some of this stuff. According to this last statement, a trapezoid is isosceles if its diagonals are congruent. So that means that I've got to make these diagonals be congruent to each other so that my trapezoid will be isosceles. So 12x minus 11 is going to equal 9x minus 2. And all I need to find is the value of x. And we'll type it in. What am I going to get? Equals 9x subtract 2. X is 3. Why do I keep doing that today? X is 3. All right, so there's one more thing that you need to know about trapezoids, and that's the mid-segment. So this is a little bit like the mid-segment theorem that we learned with triangles, with a little twist. The mid-segment is the segment whose endpoints are the midpoints of the legs. So what it's saying is I have a leg here, and this point is the midpoint, and this is the midpoint. So that's a midpoint. And over here it's a midpoint. And then what I do to get the mid-segment is I basically connect those dots and I draw the mid-segment. So what this is saying is that the mid-segment of a trapezoid is going to be parallel to each one of the bases. So my mid-segment is here in the middle. It's going to be parallel to AB, and it's going to be parallel to ED. And that mid-segment is 1/2 the sum of the bases. So this is what it's going to look like. This mid-segment is going to be half of the other two sides when I add them together. All right? How does that work? Quite simple. Here's my mid-segment, EF. EF is half of the other two. AD plus BC. So you're going to see the formula it's not going to be exactly the same formula every time. It's going to be mid-segment equals half of the parallel base plus the parallel base. I really need you to start getting used to these formulas in words and descriptions and not simply just X's and Y's all the time. That's going to be really important for the unit that's coming up next. It's all about circles, okay? So EF is what we're trying to find. It is 1/2. So parallel base, 13.5, plus the other base that's parallel is 8. So now I'm just going to type this in. I'm going to be really careful when you type this in. I'd hit that division bar first and get that fraction out in the front. Make sure you get your parentheses in there. And now we're just going to say 13.5 plus 8. I'm going to get that. Daggone. I'm going to get that EF is 10.75. Okay, last example. EH. Okay. So EH is what we're trying to find, and I'm going to put an X there for EH. So I'm going to start with the middle. I'm going to write it out like that again. Mid-segment equals half. I'm going to run out of room right there writing it. Let me write it down here below here. So mid-segment equals half of base plus base. Okay, so the mid-segment is 16.5. Or here, I'll write it with some letters so you can see that as well. So the mid-segment is XY. It is half of the base. Well, one base is EH, and the other base is FG. Okay? So the bases are all what runs parallel. So this is a base. This is a base. So let's plug in the numbers now so we know what to type into Desmos. So XY is 16.5. EH is X, because that's what I don't know, and that's what I'm trying to find the answer to. And FG is 25. So now, type that into Desmos. What am I going to get? 16.5 equals 1/2. 1/2. I need some parentheses. X plus 25 parentheses. And now I'm going to stop and see if everything looks correct. Did I type it in? Yes, I did. X equals 8. What was I trying to find? EH. What was X in my problem? EH. All right, I'm good to go.